Hello friends, welcome to the second video of the regression methods, the common regression methods. In last video we have seen the linear regression techniques, how exactly the equation of line can be applicable to the data set so that we can easily predict the next value on the line. Now let's go for the second way of using regression is the polynomial regression. A polynomial regression is a special case of linear regression, as linear regression have two axes, x-axis for the value, data value, and y-axis for the output value, that is target value. Considering the real world example, the data might not be so linearly but more scattered. In such cases, linear regression might not be the best way to describe the data. A curved or non-linear line might be better fit for such data. Okay, exactly, the line is not possible. In that case, we are going to create a curve, and that curve decides the fitting of data on the respective model of the algorithm here. Now let's see the polynomial features. What do you mean by it? Now the equation of quadratic equation or the polynomial degree of 2 is like this. See, y is equal to b0. So here we have the b0 is the intercept plus b1x plus b2x square. Okay, so this is polynomial degree 2 that we are going to make use of, right? Now similarly, the equation of degree 3 will be output variable is equal to b0 intercept plus b1x, okay, b2x square plus b3x cube, in this way. Okay, so here we are going to make use of so if x is the input variable and then b1 and b2 are the coefficients which are multiplied over here in degree 2. In degree 3 we are going to multiply x square, x cube, like this. So polynomial degree n would be like this: b0 plus b1x plus b2x square plus b3x cube plus bnx raised to n, where n is the degree of polynomial. Okay, so let's take an example how exactly it is done. Now when polynomial degrees are used, this kind of the curves are generated. In general linear regression we are having a line only. Now for polynomial regression we are going to create the curve, something like this. Let's take an example and then go ahead. Now for the same, now remember polynomial regression is not a separate class here. Okay, it's a special case. So linear regression requires the pre-processing step called as polynomial features. Now polynomial feature function is present inside the scikit-learn's pre-processing library, by which you will transform your data from linear format into the polynomial format. How it does? Let's take an example. It works quite simple actually. It takes a matrix of features and transforms it into matrix with quadratic in nature in degree of 2. Let's see, for example, I am having x something like this. Two features are present inside it, a 0 to 4 and b is 1, 3 and 5. Okay, so in this way the matrix is formed. And now how polynomial features will be applied. So this is how example mentioning from scikit-learn, sklearn. Polynomial features, I am maintaining degree 2 there, and object is created, and when you fit and transform the expected data into polynomial feature format, how it will be converted. Let's check it out. The first row is becoming 1 only. Okay, then original data here a and b, then a square, then a into b, then b square. Okay, in this way it has transformed. Means 2 columns are expanded in 6 different columns. Out of that, first column is always 1 and remaining other columns will be like this: original, then square, then cube, then raised to 4, raised to 5. On that way the data will be expanded and that will be stored in the respective data set. So our case here, the data set which is expanded is poly underscore x. Okay, now let's see how to use it in actual example of polynomial regression here. Now I'll continue with my original data set, that is the salary and experience of the persons. Sorry, we'll just continue with this data set here. Okay, So we have seen the analysis of this particular data with the help of linear regression. We got almost 93% accuracy in the testing data, and overall accuracy is almost 95% present in this particular data set. So I've splitted the data. So basically I'll not split the data in this case. Directly we'll apply the data set and check the accuracy of this algorithm on this particular data set here. So let's go for this. I'll be reading this file, okay, applying simple general linear regression to all the data sets. So let's read the pandas and the numpy, read the file, okay. Then we have read the data experience from here, experience values, and reshaped, because we have seen already values convert data in numpy array format, and then the data we are transforming from single dimensional into multi-dimensional data sets. Okay, so that's what operations are done here. Then I'm taking output variable salary into y. X is the input, y is the output. Now let's read the linear regression class from the sklearn.linear_model. Now create the object of it, linear regression. Now feed the data to the statistical model of regression. Okay, so we have fitted it, and finally we are going to check the accuracy of all the 30 entries present inside this data set, and let's see what happens actually. So this is how we are going to make use of. Let's continue with this. Now let's check it here. Okay, so accuracy is equal to np.round. So I'm rounding off because lot many digits are generated after the dot, so rounding it to 3 digits only. Regressor.score, x and y are given as input. Then what is the accuracy? 95.696 is the accuracy of this data. It means that salary and experience are linearly connected, but they are having accuracy of 95.696 only. Now this is regarding the simple general linear regression. Here I have done few more tasks here. So let's see. I want to apply the polynomial regression to it. Now how to apply that? So from sklearn.preprocessing I am importing the polynomial features class. Polynomial features, as we have seen on the presentation, is the class which is used to transform the data from linear format into the polynomial format. So let's insert one more row below. Create the object of this polynomial regression. Poly is equal to, okay, polynomial features, and there we have to specify degree is equal to, for example, I'll provide 3. Yeah, okay, so it's executed. Then we'll apply xp is equal to poly dot fit underscore transform x. So x, okay, it is transformed, and after this we are going to, let's insert few more cells here. Okay, so data is transformed, and after the data is transformed we are going to perform the fitting operations. So let's see how exactly data is fitted and what can be the output in this particular case. Okay, just check what is, okay, linear object linear regressor is not callable, and just to not use the fit method here. Check the errors how it generated. Okay, now regressor.fit xp is the polynomially transformed data that we have seen. Just check it out what xp is showing here. See what I have explained. So here all first is 1. This is 1. I am using polynomial degree 3, correct? So 1, all are 1. Check it out. Just I 1.0 into e raised to 0 means 1.0 into 1, that is 1 itself. Then this is the square. Okay, square of respective number, sorry, original number, not square. These are the original numbers, 1.1, 1.3, 1.5 onwards. These are the square of them. Okay, and this is raised to 3, polynomial degree 3. So this is 1, then this is x square, this is x cube. Okay, so in this way data is transformed, and after that we have applied this data to the regression methods here. Okay, so regressor.fit xp and y. Now let's go for this. This is why accuracy for general purpose data set, linear data set, not polynomially transformed data set. So let's check the accuracy now for polynomial transform data. Now check this out. 95.696, where we have 96.36, means almost 0.70% accuracy improvement we are getting over here when I am using polynomial degree 3. In case of polynomial degree 3, the data points are more approaching toward the center of the line. That's why accuracy improvement we are achieved there. Now what we'll do, for this case I will make it 5 here, and then we'll check the accuracy. Yes, 96.65, almost somewhat decreasing in the accuracy we are getting here. Polynomial degree 5, then go for polynomial degree 7. Now let's check how much curve you are generating. Yes, 97.226. Now we are improving it. It doesn't mean that it will reach toward the 100%. It may have accuracy above at some maximum level, and above that this curve will start changing again, and accuracy will get decrease after it. So what I'll do, I'll show this in the form of a graph. So let's see, import matplotlib.pyplot as plt. Okay, then plt.plot. So let's have the scatter plot first with the original values, scatter of xp comma y, and plt dot plot xp comma regressor dot predict xp. Okay, just a minute, what's output? Okay, x and y are of not same size, that's why you are getting this output here. Okay, just a minute. So here also I have generated that same method. Okay, sorry, my input parameters are original values should be present. Okay, this is what the original values I am having, and I predict on the transformed values. Now look at this, how the curve is actually generated for degree 7. This is I'm generating for degree 7 original data here, and then the line. So lines color I will change here, color is equal to R. Now see this, in this way the polynomial curve is generated, and it is these points are coming closer to the center of it. That's why we are achieving the accuracy improvement for this particular case. This is what we call as polynomial regression. Okay, so we are having 97% accuracy for this case. Okay, what we are achieved here currently right now. Okay, for degree 7 it's shown there. So when I decrement this degree, I'll make it 4, and now check this out, 96. Yes, okay, so almost somewhat curvish we are achieving from this, and 96% accuracy is there, but improvement from the linear regression is achieved. So when you are incrementing or changing the degree of polynomial regression, as per that this data may come close toward the center or may go away from the center, so that a perfect accuracy achievement are possible. Okay, so accuracy may be improved or accuracy may be decreased. So we need to identify at what exactly polynomial degree we are going to have highest amount of the accuracy. So to do this one, I am creating one loop, and with the help of that loop I am finding which degree is having highest accuracy. Now let's see this. What I have done here, I am creating a list in this is an empty list created, and then after that I am starting my n in the range 2 to 31. Okay, so n means the degree value start from 2 to 30 actually. Then I am creating the object of polynomial features, degree is equal to n. So degree will start from 2 and will end in 30. Okay, after that this object is created. I will be using pf.fit transform. So apply this data set, our data set, transform this data, and that data is xp, and then I am applying this data to train the model xp comma y. Okay, and once the data is trained, algorithm is trained, I am whatever accuracy I am achieving, that is round of accuracy, np.round regressor.xp.y into 100. Okay, this accuracy value I am appending to this particular list, acc.append. Okay, so accuracy what you are achieved, you are appending to this particular list, and the list will be formed. Okay, so let's see, the list is formed. and then I'm printing the maximum of all. But basically before printing maximum, I'll just check all the accuracies from 2 to 30. Check this. 95 is 2 degree, 96, 97, 98, 97, 95. See this one. Then again it started decreasing. 95, 94, 93, 92, 91, 84, 83. Means at certain level, I think this is the highest accuracy that is achieved. Here also. Maybe somewhat differences are there after 4 or 5 decimal positions. But this is the highest accuracy that we have achieved in this. So by this array, I have identified where the highest amount of the accuracy is present. So highest accuracy is 98.302. Now I want to show it on the graph. So to do this one, what I have done, here I am creating a plot. Okay, so x label degree, on x side I am showing a degree which start from 2 to 31. Y label I am showing accuracy. So here 0 to 30, x limit, y limit are almost 80 to 100. This is accuracy's limit I am specifying, and then grid I am showing over there. After that, plot it. So plot range 2 to 31. Okay, on x side we have the value of n, y side I am having value of accuracy, and color is equal to red. Okay, and by using scatter plot, I am showing the point where highest amount of the accuracy is achieved. Okay, scatter. So ACC dot index of accuracy plus 2 I am applying over here, because my minimum value is 0 and minimum value of index of array is minimum value of index is 0 and my minimum value is 2 here. That's why I am adding 2. Then maximum accuracy, color is blue, size of the dot is 50. Okay, so once you execute that, you just can check it out. Here this is a line plot generated by plot, and scatter generates this dot, maximum of accuracy. Okay, maximum of accuracy, that is this color particular blue dot is there, maximum accuracy. It means that almost at 12 position, we are 12 or 13, 12 positions, I am having the highest amount of the accuracy present. And you can observe that accuracy has started increasing from here almost, and here we have highest accuracy, and after that it is started decreasing. Okay, so this is your threshold point, highest point, the peak point where you are having the highest amount of the accuracy, and that point, that degree will consider in prediction of the data. So how to do this one? So let's go for that. Degree is 13, so highest amount of degree is 13. I think 12 and 13 both are containing same values there. So PF is equal to polynomial features, degree equal to 13, then fit transform, then fit to the statistical model of machine learning, regressor dot fit. Okay, apply this data. Once it is applied, then find a score. Yes, 98.302. Okay, so that's how it is possible. And finally, I'm going to show you it on the plot format. Let's see, plot xy, and I'm using O. Okay, you can use dot also, so it will be more clear. Yes, let's see this, and plot xy regressor dot predict xp. Okay, so this is just like a scatter plot, and here prediction is done on the polynomial values. So when predictions are done on polynomial values, let's see how this particular curvish line I am generating out of it, and these points are coming more and more closer towards that particular curvish line of predicted values. Okay, so that's why accuracy improvement is there. Now prediction is also done almost in the same way. We can achieve this, and we got almost too much improvement in the accuracy. So in this way we can achieve more and more accurate results from the linear regressions by using this special case of linear regression called as polynomial regression. You can try on your system, and most of the time when linear regression is not giving good accuracy, we can try to find, we will try to find the curve inside it, and that curve will fit your data most accurately in the statistical model of these polynomial regressions. Okay, so polynomial regression is a special case of linear regression where we are giving the accuracy to the respective input variables. Okay, so based on that, generating results are possible. This is what polynomial regression is. Now let's go for the another way to use the regression is called as the multiple regressions. Multiple regression is an extension of again linear regression into which relationship between two or more than two variables are possible. Simple linear regression have one predictor and one response variable, but in multiple regression we have more than one predictor variable and one response variable. Now how mathematical equation can be used? Let's say this: y output variable is equal to a plus b1 x1 plus b2 x2 plus b3 x3 till bn xn, like gone. Now here a is the intercept, okay, then b1, b2, b3, b4 are the coefficients that we are going to multiply for the respective input variables there, okay, till n number of elements. So these are the input features: b1, b2, b3, bn are the input features. N number of input features are there, which are multiplied by the coefficients that we call as a slope. Okay, so in this way this line is generated, this equation is present, and based on that we are generating the output value y. Okay, so this is just again an extension to the linear regression class. So response variable is y, a is the intercept, and b1, b2, b3 till end they are called as coefficients or the slopes. Okay, and x1, x2 are the input variable that we call as the predictor variables to the particular data set. Now let's apply this. How exactly going to make use of it? So every input variable can be positively connected or positively or negatively connected to the output variable. Consider the data set emptycast.csv. This data set, I'll show the data set present over here. This is first data set. Now the second one is this. Okay, so let's look at that. Here in this case I'm having this particular car. This is empty cars data set. What exactly it represents? This data set is containing this output variable, mileage of the car, mpg. The mileage of the car is given, and these are the input variables that is present. Now based on all these input variables like number of cylinders, displacement, horsepower, draft, weight, cubic, vs, automatic or manual, number of gears, carbon level, based on all these input variables we are going to identify what exactly the output variable is generated. So in the equation of multiple regression we are going to fit this particular data. Okay, so how it is possible? Now basically we are having lot many inputs here. So almost 1 2 3 4 5 6 7 8 9 10 inputs are there, and one output variable. So it will be complicated to see. So what I'll do, I'll take three input variables here: displacement, HP and WT. Okay, so as per my knowledge these three variables may affect the output parameter, that is mileage of the car. It may affect the mileage of the car. So I'll take this as input, and based on that mileage of the car can be identified. So let's see this. We'll try to fit this data into multiple regression, try to find the coefficient, intercept and accuracy, as well as prediction and the graphical representation of the relationship. So let's go for this. Okay, now let's import the pandas and numpy, and then read the file, csv file emptycast.csv. let's check the shape. So if the shape is identified, 32 rows and 11 columns are present inside it. Okay, 32 rows and 11 columns. Out of that 3 columns I am giving as input, that is data, displacement, HP and WT. They are in X, and output parameter, that is mpg, I am putting into Y, that is the output variable. Okay, input and outputs, x dot head. Now let's see, 3 parameters I have extracted from this emptycast.csv file. These 3 parameters I am storing in X, and then check first 5 entries, means we can easily create use a snapshot of this particular data set here. So total first 5 entries are shown over here: displacement, HP and WT. Okay, so these 5 entries are present here. Now for multiple regression there is not a separate class defined. Same class I need to import from the linear underscore model. From sklearn.linear underscore model, import linear regression. So linear regression class we have imported. Okay, then create the object of it, linear regression, then fit it. So I'm trying to fit it, regressor.fit x and y, x input, y output. Now in this case we have not reshaped our data. Why? Because data is already present in the multidimensional, that is 2-dimensional format. So reshaping is not required. Now onwards, for any of the algorithms we don't require the reshaping, because almost everywhere we are going to have the multiple data input, multiple features input. That's why the transformation from single dimension to multi-dimension is not expected in that case. Okay, so transform So fitted, and now let's see the score. 82.68. So score is identifying the accuracy of this data set, or so we are going to have that 82.68%. It means that this accuracy is above threshold level of 80%. It means that we can easily use this. Maybe if you use all the 10 features, you will have good accuracy more than 82%. Okay, for this example only, I am taking only 3 inputs, and based on that accuracy score is identified. It means that now displacement, HP and WT are affecting the MPG 82%. Getting this? Now once you fitted the data, we got the coefficient values here. See, COEF, 3 coefficients are there as per the equation B1, B2, B3. Okay, 3 coefficients are present. These are generated over here. Okay, check it out, this coefficients, and intercept is this 37.10, because only one intercept is there, and the coefficients are 3. Now let's take an example. Now let's do the predictions. We got the accuracy score. Now let's do the prediction based on some new values given there. Now new values will be like this. For example, I am going to have the 221. So let's see this. I am fitting this value in the equations. Let's try this. 221 is the displacement. Okay, when 221 is the displacement, okay, I am multiplying it by the coefficient of it. This is the coefficient of it. Then 102 is horsepower. Sorry, yes, 102 is the horsepower. Okay, so that is multiplied by the second equation, that is second coefficient, and third is the weight, 2.91 tons. This is the weight of the car into this particular coefficient. Okay, and plus intercept, plus this intercept I am adding over here. So this intercept is added. So let's see this one and predict the mileage of this car. Yes, mileage of this car will be 22.65. Okay, this is how I calculated with the help of equation. Now same case is possible for with the help of predict function also. Let's say this. So what I have done, these new values I am providing in the array format. Say this one, regressor dot predict 221, 102 and 2.91. Okay, so these values are given as input to it, and based on that we are going to predict. So we are prediction is 22.65. so if you predict that 22.65, this is the value which is generated from the prediction. So when new inputs, new displacement, HP and WT are given, we are going to predict these values out of it. 22.65 is the mileage of the car. Okay, see, equation also generating the same, but advantage of this is we are going to achieve the automations here. Means automatically, as per the statistical model build, as per the coefficient and intercept generated, we are going to predict these values here. So these values are predicted. You can check it out, 22.65. Okay, so this is how the prediction with linear regression or multiple regression is possible. So we can take any number of such inputs, and output will be generated accordingly as per the equation identified by the linear regression class. And now let's have a plot of it. Now remember, plot on single plane is possible, but here we have variations in the data. Variations means, see, horsepower is in 200s range, sorry, displacement in 200s range, horsepower in 100s range, and this is almost 1 to 10th range only, the weight of the car. That's why if you plot them on single plane, it will not show correctly. So what I'll do, I'll plot them in the subplots format. Subplot format. How to use these subplots? So here, first plot I am creating here, 2 to 1. Okay, so of 2 by 2 matrix format I am creating the plots. So 2 by 2 first matrix, 2 by 2 second, and 2 by 2 third. Only fourth will be empty. So in first location I am having displacement against output, MPG, color red, and label I am giving displacement there. Then here 2 to 2. Okay, 2 to 2, horsepower against MPG, color green. Okay, and 2 to 3, that is on third position in the matrix, will be having weight against the displacement. So let's see which relationship are positive and which relationships are negative in this case. So if you run this, let's have a plot. We'll run it again. Okay, let's say this. Yes, these are relationship 2 by 2 I am creating. So 2 rows and 2 columns. Here This is 1, this is 2, and this is 3 number of plots I am showing over here. Now if you consider this particular relationship, this relationship is negative, this also negative, and this also negative. It means that when displacement increases, mileage of the car decreases. Again, when the horsepower increases, mileage of the car decreases. When weight of the car increases, okay, weight of the car increases, then the mileage of the car decreases. So this predictions, this identification we can do from here. Okay, so see the ranges here. Its range of displacement almost 400 to 500 is there. This range is almost 350 till 350 only. This range is 125 till 6 only. That's why on same plane they are not possible to show. If the ranges are same, then it is possible to have the comparison of all them together. But this is what my predictions are. It means that displacement HP and WT are negatively connected to the mileage of the car. Okay, this is what we have identified out of it. And how it is, one more thing is there. If you see these coefficients, if coefficients are negative, then most of the time the output variable is negatively connected to the respective variable. Okay, that identification is possible from this negatively connected when the values are negative. Okay, so in this way the predictions are possible, and analysis of the data when output is in continuous format, that is when it's not having a fixed classes, in that case we are going to apply any one of these regression methods. So as per our identification, either we can use linear regression, multiple regression, or the polynomial regression to transform your data. So when they are linearly connected or they are polynomially connected, that we have to identify, and based on that we are going to try, we are going to apply the particular regression method to do the predictions on the given data set. Okay, that's from my side. You just can try the system, the program by your own. If any doubts are there, you can contact us. Thank you. Thanks a lot.